We use these things every single day, but have you ever really stopped to think about what's happening inside that glowing box on your desk? It feels like straight-up magic sometimes. Well, in this explainer, we're going to pull back that curtain. We're going to follow the journey of a single mouse click and find out how a computer actually works.
Right? You see the monitor, the keyboard, the mouse, but the second you touch them, this whole invisible world springs to life. It's like a crazy flurry of activity inside, but believe it or not, it isn't magic. And it's probably a lot simpler than you think. Let's dive in.
Okay, so first things first, what even is a computer when you strip away all the fancy logos and technical specs? Let's get right down to the basic idea.
Okay, that sounds a little textbooky, I know. But here's what it really means. At its heart, a computer is just a data juggling machine. It takes stuff in, it thinks about it, it shows you the result, and it saves some of it for later. That's it. Everything you do, from watching a movie to typing an email, fits perfectly into that simple little model.
These are the four pillars, the four fundamental jobs of any computer: input, storage, processing, and output. Just remember those four words. They're basically our roadmap for this whole journey. Every click, every keystroke, it's all going to follow these exact four steps.
So, let's start at the beginning. How do we, as humans, even talk to this machine? Our journey begins with the very first step, giving it a command. Your keyboard, your mouse, that microphone, a webcam, these are all input devices. They're the physical tools, the hardware, that act as a bridge. They translate your real-world actions, like a click or a key press or the sound of your voice, into a signal the computer can actually understand.
And this really gets to the heart of what a computer is. It's got two parts. You've got the hardware, that's the physical stuff, the body you can actually touch. And then you have the software, that's the mind, the ghost in the machine, you could say. It's the set of instructions that tells all that physical hardware what to do with the input you just gave it.
Okay, so you've clicked the mouse. The command has been sent. Where does it go? Well, it goes to the most important part of the entire system. It goes to the brain. The central processing unit, or as we all know it, the CPU. This little chip is the engine of the whole operation. Every single instruction, every calculation, every decision the computer makes flows right through this thing. This is where the actual thinking happens. Now, the CPU itself is kind of organized like a busy little office. First, you've got the control unit. That's the manager, walking around, directing traffic, telling everyone what to do and when. Then you've got the arithmetic logic unit, or ALU. This is your numbers guy, the super fast specialist who does all the math and logical comparisons. And the registers? Think of those like little sticky notes. They're tiny, super fast places to hold the exact piece of data the CPU is working on right this second. So the CPU is the brain. But even a brain can't hold everything it needs to know all at once. It needs a workspace, and it needs a place for long-term storage. And that's where memory comes into the picture.
Now, this is a really, really critical distinction to make. The computer needs a fast, active workspace for what it's doing right now. And it needs a slower but permanent storage space for everything else. Confusing these two is where a lot of people get tripped up when they're trying to understand computers.
Here's the absolute best way to think about it. RAM, or random access memory, is your desk. It's for the files you're actively working on right now. It's super fast access, but it's temporary. When you turn the power off, whoosh, the desk is cleared. Your hard drive, on the other hand, is the giant filing cabinet in the corner of the room. It stores everything permanently, but it's a little slower to get things from. So when you open a program, the computer is literally pulling a copy from the filing cabinet, the hard drive, and placing it on its desk, the RAM, so the CPU can work with it.
Okay, so you've clicked. The CPU processed the command. It used data from its desk, the RAM. Now what? I mean, the computer has done its job, but it needs to tell us what the result was.
And this is the final step in our journey, output. Your monitor, your speakers, even your printer, these are all output devices. Their entire job is to take the processed information, all those ones and zeros, and translate it back into something a human can actually understand. Pictures, sounds, and words.
So let's recap that whole journey real quick. Number 1, you provide input with a click. 2, the CPU starts to process that command. 3, to do its work, it accesses what's being stored. It grabs what it needs from the permanent hard drive and uses the temporary RAM as its workspace. And finally, 4, the result is delivered to you as output on your screen. Input, process, store, output. That is the fundamental loop of literally everything a computer does.
Now, once you understand this process, you start to see the computer's true nature.
You see what makes it so incredibly powerful, but also what makes it so vulnerable.
I mean, a computer's superpowers come directly from this process. They are unbelievably fast. We're talking millions, even billions of instructions every second. They are accurate to a degree that is just mind-boggling. And they have endless diligence. They never get tired. They don't need a lunch break. This unique combo is exactly what makes them so revolutionary.
But here's the catch. A computer's greatest strength, its amazing ability to follow instructions perfectly, is also its single greatest weakness. Why? Because it will follow any instruction it's given, even the malicious ones.
And this is exactly where we get digital invaders. Viruses that latch onto real programs, Trojan horses that trick you into running them because they look useful, and worms that can spread all on their own. All of these things simply exploit the computer's blind obedience. They give it bad instructions, which the computer follows perfectly, and that's what leads to all the damage and data theft.
So at the end of the day, a computer is just a tool, a really, really powerful tool, but a tool nonetheless. It has no will of its own. It just follows our commands with incredible speed and perfect accuracy. From that one simple click we traced today, all the way to the most complex artificial intelligence, it all just boils down to the instructions that we choose to give it, which leaves us with a pretty big question. What will we ask them to do next?